Hello, my name is Carlos Rumbo, and I am a senior researcher at ICRAM in the Department of Toxicology of the University of Burgos. And today in this chapter, I'm going to speak about the toxicological evaluation of new materials. So first, we can start defining the term of toxicity. It can be defined as the ability of a substance to cause a harmful effect when administered to a living organism, and also as an adverse change from normality, which may be irreversible. This term is very important in the new materials development because it's very important to know how these materials can reach the environment and how they are going to affect the human health. So in this figure on the right of the slide, you can see a scheme of this. It's more focused on chemicals, but it can be also applied to nanoparticles or to materials. So first, it's important to know how these materials can reach the environment, where they can accumulate in the plants, in the animals, in the soil, in the water, and from there they can reach the human body. And also, in the case of workers, they can be directly exposed to these materials. Once that the material in contact with the human body, they can be uptaken by different means that will depend on different characteristics of nanoparticles, such as of the particles in general, such as the size, the morphology, the chemical composition, and once inside, they will reach different organs or tissues. So, in the development of new materials, normally there are two factors that are considered in the research. First is the properties that this material will present. Normally, the researchers want that this new material present outstanding properties that allow their introduction in the market or that improve the existing materials. And in the case that other materials that want to substitute the traditional materials, for example, I'm thinking in those materials that present in their composition critical raw elements, the researchers want that these materials present acceptable or comparable properties with the traditional one. Other factor that is also considered is the cost effective of this material. So the researchers want that in some of the process involved in the development of the materials, I mean the production or the development, involve cost-effective processes. So these are the economic issues. Another factor that is also very important and not always is considered is the safety of this material. So it's very important to know the human and the environmental impact that this material will represent once that is released on the environment. So according to this, it's easy to understand that the toxicological studies are very relevant in the field of the development of new materials, because they're essential to determine the safety of this new material before they can be applied and their use become more widespread. So it's very important to assess the health impacts of the new materials and the means of exposures, considering both occupational workers and consumers. In this regard, in this figure on the right, you can see the different vias by which the materials can reach the human body, which are the inhalation, the ingestion, and the dermal uptake. And as I said in the previous slide, it will depend on the characteristics of the particles or the particulates that form this material. As I said, the size, the composition, the morphology. And a part of the human health is also important to know the effect of this material in the environment. So the test this test applied on various biological systems will provide valuable information about the dose that can result toxic for the environment or the human health, and for other specific toxic effects that the product of interest can produce. And how can we study the toxicity? Well, we can apply different methodologies, and to do this, we need to use model organisms. Regarding this, we have a broad portfolio available of model organisms that can be used to study the toxicity of a material. Basically, the experiments consist in expose these model organisms to the materials and study the effects that it produced. And regarding the model organisms available, we can distinguish several kinds depending on their complexity. ranging from the most simplest, which are the prokaryotes, the bacteria, to the most complex organisms, which are the animals, that they provide the more realistic and accurate results, because we are working not only with a specific human cell line or specific tissue, we work with a whole organism, but their use is more restricted and controlled because they involve several ethical issues. Anyway, between them we have different complexities of organisms that can be applied in these assays, and using representatives from different biological kingdoms, we provide most accurate information, because we can test, we can use organisms representative of human health or the environment. And finally, regarding this, to avoid the use of animals in experimentation, in vitro toxicity studies are essential tools to provide preliminary information about the potential hazards for materials. They present several advantages, which are they are cost-effective and easy to use. The organisms that are used present a very well-known structure and molecular organization, and they can pave the way for more complex studies. And finally, the most important one, or one of the most important, is that they bypass ethical concerns, because they comply with the 3 R's principles, which are the ethical guidelines for the research using animals, which are the replace, in vitro assays substitute as much as possible the use of animals in the experiments, in the research. The other R is reduce. In vitro assays allow to reduce the number of animals in experimentation, because with in vitro assays we can obtain previous information that will help us to organize the subsequent experiments, decreasing the number of animals. And finally, the other R is refine, which is not related with in vitro assays, but it means it's related with the reduction of stress of the animals used in the experiments. So finally, in the mark of the project comprise, we test the materials the new catalyst developed using in vitro assays, and to do that we use different model organisms. We work with human cell lines, specifically with human cell lines obtained from lung, and then as environmental representatives we work with the yeast Saccharomyces cerevisiae and with bacteria Vibrio fischeri.